Okay, this is 2.4. Very important video for the rest of the year. This is your lesson on how to do proofs. So some of the things you need to know is you have to know your vocabulary as far as what the words are. You don't necessarily have to give me a definition, but you have to have certain things memorized. And some of the stuff is going to be very simple, such as the addition property of equality. That just says that you add something once on the left side and once on the right side. Same thing with subtraction property of equality. You're adding or subtracting something on the left and the right side. All right, so these are the reasons you're going to give, and you're going to see in a second when we're using these. But I wanted to show you on the next page of what we started with. This is the list of the vocabulary you're going to need to start with. Multiplication property and division property of equality. Those are, it looks like you're doing it once on each side, but technically speaking, the rule is you have to do it to all terms. Usually in algebra, you've whittled away at the problem until there's only one term on the left and one term on the right when you actually finally divide or multiply in the equation when you're solving. But the rule is when you're multiplying and dividing, you must do it to all terms. Okay? You can add and subtract by anything you want. You can multiply and divide by anything you want. But hopefully you do it with a purpose. Okay, and then you have the substitution property of equality. Now we're going to abbreviate all this stuff. Please abbreviate the way I do so that there isn't a question, because if I don't know what you're saying, I have to count it wrong. All right, so let's go on to the next one. This was the first page here. This is called a two-column proof. So you would draw a vertical line, and here's the problem that is given to you. And on the right side, the justification or the reason, you would say given. So whenever you did your math homework, you'd open up your book and you'd look at the problem. That's the given part. They give you the problem to solve. Please make sure you always write given after the given stuff. Why would I say this over and over again? Why do I do it every time? Because these are things that students miss. They write something very silly in that spot. Okay? So make sure that whatever's given, you write in the reason column given. All right, so my next question to you is, what do you do from the given to the next step? What did they do? Purcell? All right, they distributed the 2. So we say that is the distribution or distributive property. Okay, and you can write just DIST for distributive if you want, and PROP for property. And then the next question is what they do from that step to the next step. Chapin. They subtracted. So really what you're doing is you're combining like terms. Okay? So combining. I'll write it out, but you can just write COMB. Combining like terms. Right? Didn't they just combine 6 and negative 5? Yeah, really they subtracted, but the 6 and negative 5 were already there, so you're combining them. What they do from there to the next step? Chapin. They subtracted negative 2x on both sides. So you would say the subtraction property of equality, and that's the proper way of abbreviating it. If you just say subtraction or substitution and you abbreviate both of those as SUB, how am I supposed to know which one's which? And I will have to count it wrong. So make sure you don't get lazy. All right, so what they do from that step to the next step? Have you caught on yet? What'd they do? How'd they get the 3x? Yeah, they put the 5x and the negative 2x together, didn't they? And they put the 2x and the negative 2x together on the left. They combined like terms. So let me stop right here for a second. There is never anything that's done in mathematics that doesn't have a reason. It's not magical. You're not a bunch of wizards that just say, oh, this is how it is. Shortcuts are not mathematical. There's a reason behind them. It's just you've memorized how to do a lot of stuff. So when you get to pre-calc, I explain some of those shortcuts to you because it keeps you from knowing how to do other things when I take the numbers away. Okay? So combining like terms. Now, from here to the next step, what'd they do? See if you can start saying it properly. Chapin. Well, they're just now subtracting the 4. So it's subtraction property of equality. They minus 4 on both sides. And then the next step. Combine like terms. Lake. What'd they do in the next step? Divide it, so that would be the division property of equality. And then we'll come back to this here in a minute. Excuse me. Okay. Whoops. This right here, again, is probably in the top 5 things you're supposed to learn and know in geometry. Understanding how to break down radicals is probably in the top 2. These are definitely in the top 5. You will use these properties all year long. So they seem kind of silly. The reflexive property seems really silly. A equals A. Well, yeah, duh, right? Well, here's when you would use something like this, or an example. If I had 2 triangles, this triangle here, we'll call this point A and point B, and there's another triangle attached to it, and they share that side, right? Don't they share segment AB? Okay, so segment AB in the left triangle, isn't that the same thing as segment AB in the right triangle? Okay, so there is going to be a need to address both of those things, and the reason you can say that would be the reflexive property. So it seems kind of silly now, but that's coming. All right, so that's an example of when we'd use it. Anytime you got something equal to itself, that's a reflexive property, as opposed to the symmetric property. And I think the example there is good. If A is equal to B, then B is equal to A. If you want an example, we use triangles a lot in geometry. If I have A, B, C here, and have another triangle. We'll call this D, E, F. And I say those two triangles are congruent. A is equal to D, and so D is also equal to A. That's your symmetric property. And there's going to be some other times that we're going to use those things, okay? And again, until we really get into those, it's a little harder to grasp. But we finally get to the transitive property, which most students get, but once in a while we have a few students that forget. This is just like the law of syllogism. Well, not just like, but similar to the law of syllogism. You have three statements. Notice you have, if A is equal to B and B is equal to C, then A is equal to C. Or, like we said last week, if the beginning is equal to the middle and the middle is equal to the end. Very good. The beginning is equal to the end. That's the transitive property. You have got to be able to spot that when you're reading through a proof. Now, tonight's stuff is fairly simple, but we're going to come back to this a lot. Instead of properties, these are going to become theorems eventually, okay? In multiple ways. Notice we have real numbers, then we have segments, and then also angle measurements. So they're all the same thing in each type of problem. Okay. Excuse me. Everybody do number 1. So you're going to set up a 2-column proof. Let me help you. The very first thing you should do, and you don't have to rewrite the problem, you can just draw your line for your 2-column proof there if you want. But in general, on your paper, you would write what was given, draw a line, and then you say given there. So you can put the given on the right side of your line there if you want. That's how you should always start. Now, finish the problem. I'm going to pause this and come back to it, and we'll talk about it. All right, so in algebra, you can solve these in different ways. Okay, so how you solved it may not be exactly how I'm going to show you, and that's okay as long as you gave a legitimate reason for what you're doing. That's what I'm talking about. Whenever you're solving things, make sure you understand that you're doing a mathematical procedure on each step. That'll help you in your Algebra 2, and it's going to help you when you get to pre-calc. Okay, don't make things up. All right, the first thing I'm going to do is I like to have my x's on the left, so I'm actually going to subtract 5x to the left, and that's going to give me a negative 2x minus 7 equals negative 19. You didn't have to do it that way, okay? So what did I do? I did the subtraction property of equality. The next thing I'm going to do is I'm going to put my numbers on the right. So I'm going to add 7 to the right. And I get negative 2x equals negative 12. Notice this is a really good reason why we've always tried to get you to show your steps. It's not because we want it to look nice and neat. It's to show you that you are doing something legitimately mathematical. That's the purpose. And it helps us see what you did wrong if you made a mistake. Okay, so that was the addition property of equality. Okay, so you mentioned this not just now, but in the earlier problem, that this is like combining like terms. I'm introducing something into the equation, something new. So that's going to be the addition or the subtraction property of equality. If something's already in the equation and you add and subtract them together, that's combining like terms. That's the difference. Okay, and then the next thing, divide off a negative 2. And that will give me x equals 6, which is the very last statement. So the reason of what I did there is division property of equality. Give a reason for everything you're doing. Your work doesn't need the reason. That's why I wrote it like this instead of like what they did in the other page. But I think there might be something in your homework set that writes it the exact same way they did in the book. And really the work is the combining of the like terms, statements. So just do your best to write them out. You actually do have a few more problems than normal, but that's on purpose. It's not to be mean. I'm trying to make sure that this is really just drilled into your brain. Okay, you do have the answers. You're required to look at them. So the assignment is on Google Classroom. Make sure you use that assignment. That is due tomorrow at the beginning of class.